Good morning, everyone. Welcome and thank you for joining us for Teledyne ISCO's April Water webinar. Today's webinar is focused on vacuum versus peristaltic samplers. This webinar is going to be led by Jeff Vandehoff, Teledyne ISCO's Product Support Specialist. It is being recorded and will be available to all registrants and attendees later on this week through Teledyne ISCO's YouTube channel, and you will receive notification when it is available. If you have any questions or comments during the webinar, please utilize the chat function within Zoom, and all questions will be answered at the end of the webinar. At this time, I will turn it over to Jeff.
Hello, everybody. Again, my name is Jeff Vandehoff. I'm a product support specialist here at Teledyne ISCO. I've been here for 29 years in various departments, mainly service, last 4 or 5 years in product support, dealing with customers direct and everything. Like Tori said, today is going to be vacuum versus peristaltic samplers, give you a better idea on, which samplers you want to use in which applications, which sampler basically fits your needs better. So we'll go ahead and start here. We're going over is the components of the units and how they work, technological advantages between the two, which ones you should choose, advantages for applications, methodologies, purposes between both of the units, the vacuums and the peristaltic. Lots of decisions to make. Which one do you want to choose? It's really not as difficult a decision as you think it would be. There are a number of technical options for automated sampler collections. Most commonly fall into two technical approaches. One is peristaltic and two is the vacuum type samplers. First one that we'll go over is the peristaltic. Peristaltic uses a pump with rollers that actually create a pressure or a vacuum. It actually pinches the tube and spins, and depending on which direction the pump spins is which direction the vacuum or the pressure is created. The different components of the systems are A, which is the controller, which is right here. This is the 67 here, but there's other versions of the sampler as well. B is the peristaltic pump. That's the actual pump right here. There's a paddle in here that spins and creates the pressure or the suction. C is the liquid detector. The liquid detector for the peristaltic is a non-contact liquid detector. It is actually controlled by this tube in here expanding and contracting. It's a pressure related, so when the tube expands, it actually presses on that sensor, and that's how we know when liquid has hit the pump. The next one is the strainer. That's clearly down here at the source. That's actually what filters out, larger solid material from the actual, from the water that you are sampling. The next one is the suction line. That's what connects the strainer actually into the intake of the sampler. There's always a stainless steel coupling that usually goes. That's F. That's between that joins the harder suction line tubing E to the softer pump tubing here. There is also a G is the actual pump tube, and that's actually routed one continuous piece of tubing, and it's routed through the pump like this and then out into your sample bottle. There's usually a bulkhead fitting that it goes from the outside of the sampler to the inside of the sampler and then into your bottle. And then from the inside of that bulkhead to your bottles or through your distributor arm is the discharge tube is what we call that. And then depending on if you have a composite, which is a single bottle, or just multiple bottle, you may have a distributor arm, or the tube may just run directly into the bottle. How does a peristaltic pump operate? It starts off with a pre-purge cycle. So what it does is it clears any water that's actually in the line. Water will probably migrate up the line here, so there will always be a little bit of water in there. So the pre-purge actually runs in a counterclockwise rotation, and it pushes the air out this way and out the actual strainer. So it's actually blowing bubbles at your source. It clears anything that's in the line. It also can clear debris and stuff that's on top of the strainer. The next one is, next the pump turns and goes into a forward motion. It turns and goes clockwise. So then it creates a vacuum on the backside, and that actually sucks the water up, and then pushes it down into the bottle. Once the water actually hits the liquid detect sensor, then it knows when to start counting counts, and that's how it determines how much volume you actually delivered into the bottle. The final option is it reverses the pump and again goes in counterclockwise, and it purges all the liquid out of the line again. That way you don't have cross-contamination come the next sample. Vacuum sampler works pretty much on the same principle. It has a lot of the same components, just a little bit different configuration. It does have a controller where all the logic is done, it tells it when to sample, how much to sample, all that kind of stuff. It has a vacuum pump, and the vacuum pump is what provides either the suction or the pressure to clear or bring water up the line. It does have a liquid detection section that is usually in the sample chamber right here. Same strainers that we use on the peristaltics we use on the vacuum. Intake line, again, that's the same intake line that we use here. We also have an option of multiple bottle configuration. The vacuum samplers are a little bit different, where it actually spins the rack instead of a distributor arm. So operation of a vacuum sampler. There's two different types of vacuum samplers. Number one is a volumetric, and the second is a gravimetric. The volumetric delivery volume determined by the adjusted height of a tube. That's our CVE model. It's within the collection chamber. There's a tube right here that you raise up and down, and that controls how much volume is delivered in each sample. There's also liquid detection electrodes that are in the top of the chamber. Once water fills the chamber and touches those two electrodes, it knows to stop the pump and stop filling the chamber. Same pretty much principle here as what we're doing. We do a pre-purge on here. We have a vacuum pump that has either vacuum or pressure coming off of it. In the pre-purge thing is the solenoid switches, so the pressure is applied to the sample chamber here. Push pressure in here, and then it pushes pressure all the way out here to your suction line and purges the line. The next one, the solenoid switches, and then it switches to the vacuum sign, so we create a vacuum inside here, and it vacuums all the way up until water hits the 2 points up here, the actual liquid detection points. Once it hits those two, then it stops the actual the suction side of it. Once it hits those, then it turns and it goes to a post-purge. Again, switches the solenoid and pressurizes the system. So it pressurizes, blows the air into here up until to the bottom of this. Once we get to the bottom of this, then all the air rushes out here, and it keeps this volume right here. So when you raise this line here, this is the line that you raise up and down. If you raise it up to here, well, then you're going to have this much sample volume going in there. So it just all depends on the height of this tube here. And that's a one-time setup that you have to do. Once you have that set up, then it's going to repeat that volume every single time. The last portion of it is the drain of the sample. What all of that is really is it opens the pinch valve. There's always a little bit of pressure in here, just a little bit, that helps actually clear the chamber once the pinch valve opens, and then it just drains down right naturally into the bottle. The next option is our gravimetric, or our load sensor. We call that the QLS version. It actually weighs the weight of the water coming into the sample chamber, and that's how it determines the actual volume that you delivered. It knows the weight of the liquid, for certain volume amounts. This is the front view of the actual sample chamber inside one of our refrigerated units. Sample chamber here, right here is the pinch valve, and in behind here is the actual load sensor. Here's a bottom view. This is looking up. This is the actual pinch valve in here. The load sensor is actually above that. Here's a side view. It gets you a lot better view here. The bone-shaped thing here is the actual load sensor, and it's actually measuring the whole weight of this chamber and this whole assembly on here. So the very first thing it does when it tries to take a sample with the QLS version or the gravimetric fusion version, what it does, it takes a chamber weight. It zeroes out the weight. It actually sees what it is. Sometimes you have residue or particles will stick in there, so that the sample chamber may change weight, between different samples. So it actually zeroes it out every single time, so you get a good starting point. After it zeroes it out, then it does the same as all the other ones. It does a pre-purge, changes the solenoid to pressure, pressurizes the chamber, blows all the water out of the suction line. The next one changes direction on the solenoid, and then we create a vacuum in there, brings water in all the way up. On the gravimetric one and the load cell one, it actually is weighing that chamber the whole time. So it's a constant, it's an online thing as it's doing it. Once it actually hits the volume that you have pre-programmed into it for the controller, then it stops the pump running in the vacuum side. After that, and then it purges out the excess in there, purges out the line all the way down to the source. Then it does a verify of the weight, actually weighs it again and says, yep, I got this much. Sometimes with different line velocities or clogs or something like that, it may get a different type of number or something like that. So it's actually learning every single time. So if it verifies the weight and it says, oh, I didn't get quite enough sample, the next time it takes a sample, it will actually compensate for that sample. The last cycle on here is the drain cycle. And all the drain cycle is, it just opens up the pinch valve and lets all the water drain out into your bottle or bottles. So advantages of the peristaltic sampler. They are, but they're not limited to. We have highly accurate volume delivery. It's based on a pump revolution counter rather than runtime. Once the liquid actually hits the liquid detect sensor, then it starts counts or revolutions of the pump. Once it knows, it knows how many revolutions it has to do to deliver certain different volumes. We call that pump tables. The non-contact liquid sensor. A lot of times there's heavy solids or like paper mills and stuff like that. There are stuff that can actually coat the inside of the pipe or the inside of chambers and stuff like that. With a non-contact liquid sensor, we don't have to worry about that. It just works on the pressure, the expanding and contraction of that actual pump tube when it's pumping. Pump performance and liquid detection ensures more consistent sample volume delivery across a full range of head lifts. If the higher your head lift, the slower that the water is actually going to travel in the pipe. So we don't actually start measuring our pump or our water until the water actually hits the pump. That way we get the same volume every single time. Lots of flexible program options to allow the unit to meet different needs. Very versatile on that. Advantages of the vacuum sampler. Again, it's a highly accurate, and a lot of these are kind of the same as what the peristaltics are. Highly accurate volume delivery. This one is kind of better more if you use it if you have small volumes. If they're taking a sample every 10 minutes and they're doing 10 or 20 mils or something like that, it's very accurate at doing that. Pump performance ensures more consistent line velocity. You don't lose a lot of line velocity because it's just with the vacuum pump is what's controlling that. With the peristaltic, you have wear on your tubing, you have wear on your rollers and bushings, and all of that wears, then your suction actually decreases over time until you replace all those. The purge on the vacuums is more of it builds up pressure and then it just releases the purge. So it actually has a lot more vigorous purge. Effectively clears stuff off the strainer measure, actually clears the line better, so you don't risk cross-contamination of samples or anything like that. It also has flexible programming options. It allows you to meet your demand. If you need, time sampling, flow sampling, all that kind of stuff. Multiple bottles, single bottles. We have all those different types available. Which technology should I choose? The most significant, contributing factor that determines what to use often comes down to personal choice. There's usually a preference for one method over the other due to like standardization on one, method already. Local agencies sometimes will prefer one technology, over the other. Regional standards have settled on one technology as the preferred method. For example, 60% of stationary applications in Europe are actually vacuum. 95% of the worldwide portable applications are peristaltic. In over 80% of the applications, either method will actually work just fine. The need for advanced functions and features, that usually is more of a deciding factor than the importance of, vacuum versus peristaltic. Features such as telemetry needs, a modem if you want to access the unit remotely, or if you want to actually, call it and say start sampling, that kind of stuff. Two-part programming. If you have like a multiple bottle system, like 24 bottles, you can set up the first 12 bottles to be time-paced, and then you can have the second 12 sets of bottles to be flow-paced. You can divide that out however you want. You can do the first set you can have as every 15 minutes, and then the second set you can have as every 20 minutes or every hour after that. Data logging. If you actually need to log the data, if you're bringing in other parameters or anything like that, if you actually need access to that data and need to be able to download it, that is a big deciding factor. SDI 12 interface. If you need to bring in other parameters like YSI or like pH or turbidity or dissolved oxygen, anything like that, you can bring in anything that speaks SDI 12. You can bring that into some of our units. There are some cases where the abilities of one method, though, are more suitable than the other. For peristaltic samplers, the components of a peristaltic sampler are more robust and able to, withstand the physical strain that a portable unit is subject to during transport. You banged around, that kind of stuff. You just got a pump paddle in there that's spinning. They do take a beating. They're very durable like that. Quick maintenance. Replacing the pump tube, replacing the suction line, pretty much anybody can do. Very easy to do. You don't have any special skills or tools or anything like that, and it's very quick to do. Pressurized line applications is a lot better for the peristaltics to do that, because there's actually pinch points on the paddle, where the paddle is actually pinching the tubing and won't let actual pressurized water go by. Vacuum samplers actually have no means to actually block that water from getting to the bottle. There's an open path directly from the strainer or wherever the intake line directly to the bottle. So if you have any type of pressure in the line, you cannot use a vacuum sampler, because we have no means to stop that. With the peristaltics, we have that pinch point, plus we have other forms, we have other spas and stuff that we can offer that will actually reduce that pressure down to something that the sampler will actually hold. The peristaltics typically hold back anywhere from 12 to 15 psi on theirs. Vacuum samplers, if you have applications that have a significant head height, anything greater than 23 feet, the line velocity is not impacted at all negatively. It keeps the same pressure pretty much the whole time, and the purges and the pump and bringing up water is pretty much always consistent. With peristaltics, you lose some of that suction, when you wear the tubing and wear the rotors, like I said before. If you require a really long intake line, anything greater than 50 feet, pretty much, it's probably going to be an advantage for the vacuum sampler. The purge, again, with that longer thing, it doesn't reduce the purge at all, and it helps clear the longer lines better, and also clears everything, the debris off of the strainer better. A lot of times they use a longer intake line for in hazardous locations. The vacuum samplers can actually go, closely up to about 300 feet on their suction line rate. If you put the sampler in the non-hazardous area and then you conduit the suction line through the hazardous area, that way you don't have to have the electronics in the actual hazardous area. Very common to do that with the vacuums. Again, less physical wear and tear on the components. The only really moving components you have in here are the actual pump itself, the diaphragm and the motor of the pump, and then the solenoid valve that switches back and forth. Everything else, not really any moving parts. Also the pinch valve, I guess, as well, too. So, if you have requirements to collect very small sample volumes, anything under 40 mils, you're running the pump a whole lot just for a little bit of volume, so it's less wear and tear. You're running a peristaltic that much where you're going to go through pump tubings and everything like that, and just for a little bit of volumes. So a big advantage on if you're doing really small volumes there. We also have an option of we have a dual sampler on the vacuum. It's the Optima, and it's a dual, and it actually has two separate sampling systems in it. They can be set up however you want. You can have one side of the dual can be 24 bottles, the other side can be a single bottle, or vice versa, or you can have two 24 systems or two single bottle systems. It's nice for like a small treatment plant where you have less than 300 feet of suction line between your influent and your effluent. You can actually do everything with one sample, one refrigerated sample. It takes it all, puts it in the same unit. Very nice for small plants like that. Noise limitations. The vacuum samplers are a lot quieter. There's nothing mechanical. There's no rotor that spins or anything like that. The only noise you really get is just of the vacuum pump running. That's in a chamber that's sealed and everything like that, so it's really, you can feel the vibration, but they're actually very quiet. And that is pretty much it. We can go to see if we have any questions here. So we had a question, what is the expected life of the tubing for a peristaltic pump, number of cycles? So on the peristaltic, we have it set up, there's a counter that actually measures the pump revolutions, and every revolution of the pump is 12 counts. There's a counter inside the actual unit, and that actually counts those. For like the 67s and the 4700 samplers, right about 1 million counts is what you get. That really depends on, your suction line length. If you have a very long suction line length, well, then the pump and the stuff is going to run a whole lot longer. If you have a really short, then, it's going to take a whole lot. So the cycles is a hard question to answer, but it's basically we go 1 million counts. With the 3700 and the GLS, we set that at about 500,000 counts. Some applications you'll get a little bit more counts than that. Some you'll get a little bit less. But that's also user programmable. If you decide you're getting over 1 million counts on every one of your tubes, you can set that counter to say 2 million, and then it'll show you a warning and tell you when to change your pump on there. Next question, ISCO 5800 warranty still 2 years. Yes, there's a 2-year bumper-to-bumper warranty on the 5800. Covers factory defaults. Defects. And the next question, the QCEC warranty, what's the warranty on the QCEC samplers? There's a 2-year warranty on those as well. So the maximum suction line length, question was, what's the maximum suction line length for the vacuum samplers, and also what's the maximum height? For both samplers, the maximum height is 28 feet. The vacuum samplers, we offer two different types of pumps on there. We have a 23-foot head one, and we have a 28-foot head one. Of course, the 23-foot one is a little cheaper than what the 28-foot head one is. The maximum suction line length on the vacuum sampler is 300 feet. You don't actually enter that in there or anything, but how we figure that is the actual line velocity when you're actually pulling the water up the line is about 3 feet per second. And the most that we can run a purge cycle or a pump cycle is about 100 seconds. So 100 times 3, so we get about 300 feet is what you can do. If you're talking, if you have 28-foot head height, well, then you're probably going to get it a little bit less than that, but we generally say right about 300. With the Peristaltics, you're limited to about 99 feet, and you're limited to that just due to the programming of the controller. So, next question, on your vacuum samplers, with liquid level sensors, are there safeties built in that will protect the vacuum pump if there's a blockage in the intake line? Yes, on the vacuum samplers, that's the liquid, the liquid detect electrodes. Once that goes and hits that, then it's going to stop, and that's basically just below the fill port of the actual of the chamber. It's just below the top level of the chamber. So once water hits that, then it will stop the pump and it won't come up anymore. So that will prevent it from going back into the actual thing. We can't have a check valve in there because the check valve we have to have suction and pressure, so we have to go both directions, so we can't have any type of check valve in there for that reason. Next question. Basically, he's asking if we have a recommendation on getting a sample from a low flow streams. Our typical strainers are about an inch around diameter, and what we do have like a low flow strainer that's about just under a ½ inch diameter. It's just a small pipe, with holes in it, and it lets you take a sample from a lot smaller or a lot lower level of water. I would, probably recommend a low flow strainer for you there. Also, if you have the ability to stop or block, dam up the water a little bit as it's flowing, you have to create a little bit of a deeper pocket, for it to get it. Probably to get good sample, volume, and you don't not to suck air through the strainer, you probably want at least about 1 inch of water over the top of the strainer. That way you don't start gulping air there. Another question, on our 3700, it seems to not collect all 24 bottles. We reprogrammed it and the battery life seems okay. That's kind of hard. Could be a lot of things going there. That could be like what we were saying before on the strainers. Maybe it's a low flow time and maybe you're gulping air into the unit, and maybe there's enough to do the first half of the bottles, and then the second half maybe it runs out of water and then it can't get any more. That could be maybe a hole in the suction line, or a hole somewhere, anywhere in the whole line. That would definitely cause it to not get water there. If you have air or high air concentration in the water where you're getting lots of bubbles and stuff like that, sometimes that can have a problem with our liquid detector as well. It could also be a liquid detect issue where it's just not seeing it. Most liquid detectors, usually we don't have problems with the liquid detector at all. Usually it's something on site that's limiting or not letting the water get up to the actual unit.
Okay, and we'll take a moment to see if any more questions roll in. I do want to remind everyone that this is being recorded and will be available later on this week through Teledyne ISCO's YouTube page. I also want to let you guys know that next month we will have another Ask ISCO webinar at the end of the month with Steve McManus. So be on the lookout for more information on that. That is a webinar session where attendees will be able to submit questions, and Steve will work through those questions. It's more of a little bit more of an interactive and a Q&A focused webinar. So be on the lookout for information coming out on that. And I don't see any other questions coming in, so I want to thank Jeff for going through his presentation today, and thanks to everyone for joining us this morning. And if you have any follow-up questions after this, feel free to reach out to us, and we will route those as best as possible. So thanks, everyone, and have a great rest of your day.
Thanks, guys.